Navigation 2, Terrestrial and Coastal Navigation 1. Under STCW, Table A-2/1, that is specification of minimum standard competence for officers in charge of navigational watch on a ship of 500 gross tonnage or more. Competence, plan and conduct passage and determine position. Terrestrial navigation means method of navigation that uses navigational aids and landmark as reference point for fixing position of the ship. So number one example of navigational aids, that is the lightship, lighthouses or lighthouse, then the buoy, landmark. Okay, so we start to the topic number one, which is about the nautical chart. We have the learning outcome. At the end of the session, the student will able to describe the different kinds of navigational chart and its purpose. So, when say nautical chart, present most of information used by the marine navigator, including latitude and longitude scale, topographical features, navigation aids such as lighthouses and radio beacons, magnetic information, indication of reef and shoal, water depth, and warning notices. Such information allow both plotting a safe course and checking progress while sailing. The first navigation chart were made at the end of the 13th. Okay. Number one example of nautical chart with a different information. Then, of course, the map. So the difference between the map and the nautical chart, when you say chart, it is most focuses on the territorial water or the water, while the map, of course, focuses on the land, which is the political boundaries, cities, town, etc. Different kinds of chart. Number one, it is aeronautical chart are similar to nautical chart but emphasize such things as topography, heights of obstruction, airports, and airways. They are usually drawn on a Lambert conformal projection which correctly preserve angle between the different locations on the surface of the Earth. So in the aeronautical chart, so it is focused about the altitude of a building or the height of the building, the tower, etc. Okay. Australian territorial water only. So they updated their own chart, okay, for the obstruction in the navigation. Okay. It's one example of the New Zealand chart. Next is the Japanese chart. Japanese charts are also published by the Admiralty under similar arrangement. They too are being updated on the basis of information broadcasted by the Japanese Hydrographic Office or offices. However, the detailed list of charts in the Japanese folio can be found in the Admiralty Chart Catalog, and their correction are provided by both Admiralty notices to mariner and Japanese chart as well. So there are two types of Japanese chart, one with the prefix W and the other with prefix JP. For example, the chart printed as the W90 would contain information written in two languages, which is Japanese and English. The color of the land is gray in this chart, whereas chart printed the JP90 would contain information in English only and color of land printed be yellow. So one example of the two example of Japanese chart, which is the prefix W90 and the JP chart. So they have different only in the color of the land, which is JP90 is color is yellow, while the W90 is color is gray. Canadian and U.S. water chart. For Canadian and U.S. water chart as per the Code of Federal Regulation and Canadian chart and publication regulation, vessel navigating in a certain specific region are required to maintain keep updated only Canadian and the U.S. chart. Okay, so when say Canadian and U.S. chart, it is specific only the place in their territorial waters. You have to watch their update chart when entering the territorial water. Okay. Next one is the one example of the U.S. and Canadian chart. Okay. Next, the hydrographic offices chart. Two being from different the hydrographic offices chart have uniformity in the form of symbols and abbreviation, which have been recommended internationally and used globally. Enabling mariners to have planned passage using extensive information they required about distant port across the ocean. When you say hydrographic office chart, so it is used internationally with the abbreviation and same picture of their symbols for safe navigation. So one example of this chart. Next is the pilot chart. A chart for navigator showing direction and strength of prevailing winds, temperature, storm path, position of rock, shoal, and other information helpful to navigators. One example of the pilot chart is this. So you can see the strength of the wind, the direction. So it is useful during your plan or during the voyage planning. Okay. Next is the time zone chart. Time zone chart gives a specific area on the Earth a time of the day that is earlier or later than the neighboring time zone. By about 1900, almost all times of the Earth was in the form of standard time zone. So we have noticed that we in different places they have different time because of the relationship of a longitude from time. So it is based on the Greenwich Mean Time and the time zone Greenwich Mean Chart time and the Greenwich and the time zone using the zone description. Okay. So Greenwich Mean Time, now called the UTC or the Coordinated Time. UTC is the time standard of the world. Notice that is the example of the time zone chart. So for each longitude, they have, or for each meridian, they have 1 hour difference. So it depends upon when you're going east or west longitude. Next is the Admiralty routing chart. So this chart is essential for the use of passage planning for ocean voyage. They include the routes and distances between the major port, ocean current, ice limit, load lines, and wind process, with expected meteorological and oceanographic conditions for each month of the year. It's one example of the routing chart. It is used when you navigating at the, for example, at the big body of water or crossing the ocean to give information about the meteorological warning and the direction of the wind. It is monthly basis. So while go on board, you see the 12 routing chart from January to December. Tidal chart, a chart listing the predicted time and height of the tide and low tides for a given location throughout 1 year. So with tidal chart is one example. That is the chart you have to locate where placed it is the high and low of water. So in chart we have to record the mean low water, which means it is the lowest tides occur in one place. Next is mnemonic chart. A chart is very useful in a great circle sailing based on the mnemonic projection. This is a perspective projection in which part of the spherical surface is projected from the center of the sphere onto the plane surface tangential to the sphere surface. So when say mnemonic, okay, it's one example of the mnemonic chart. That is the difference between the Mercator and mnemonic. In mnemonic, so it is very useful when you are in the higher longitude because of their curvature. If you have noticed that the Earth is round, so when you're in the higher latitude, so they have a different distance when you are in the equator or at the middle. While the Mercator chart, okay, so we have a same from the polar and the equator. It means that they have not uh, when you are in the higher latitude, so it is different or they have a different distance from the equator because all of them it is right angle even in the higher latitude. So it means that when you are navigating in the higher latitude, so it is advisable to use the mnemonic compared to Mercator. While you are navigating in the near the equator, the advisable to use is the Mercator chart. But most of the seafarer use the Mercator chart because it is easiest to lay out their course. It is a straight line. While the mnemonic chart, when you lay out the course, it is the curved line because follow the curvature of the Earth. Okay. Next, the electronic chart display and information system or the ECDIS. The electronic chart display and information system or the ECDIS is development in the navigational chart system used in the naval vessel on the ship. With the use of this electronic chart, it has become easier for a ship navigating crew to pinpoint location and attain the direction. It is one of the development of the chart using the ECDIS. Okay, it's one example of the ECDIS. So ECDIS complies with the IMO regulation 5/9 and 5/27 of the SOLAS Convention as amended by displaying selected information from a system electronic navigational chart. ECDIS equipment complying with SOLAS requirement can be used as an alternative to a paper chart besides enhancing navigational safety. Today, you are required that all vessels have a ECDIS. So, if you have two ECDIS, so you have not required to have a paper chart. But if you have only one ECDIS, so you have required a paper chart because it means what once the ECDIS malfunction, so you have to use another option which is the paper chart. But if we have two FDs on board, so it is a paperless. They have no need to have a paper chart. Okay? At this greatly easiest the navigator's workload with its automatic capabilities such as route planning, route monitoring, automatic ETA computation, ANC updating. So one of the feature of the ECDIS is the course we have. It is easiest or easiest to use because if you have to look for the chart, So you enter only the number. Okay, and of course it is display the electronic chart. So this utilize the feature of the GPS, of the global positioning system. So ibig sabihin, so yung GPS, it is integrated to the ECDs. So they have easier to locate the position of your vessel. So one of the difference between the ECDs and the paper chart, in the paper chart, you cannot see the progress of your vessel. But the ECDs, you can see the progress of the vessel. Okay. Okay. So raster chart are direct copy or scan of the paper chart. It is look identical to the paper chart as all the information show directly printed. The chart only grow larger or smaller as per zooming, and when rotate, everything rotates. So in the raster chart, it is a photocopy or scan chart. So one of the disadvantage of the raster chart, once that you have to move one item, so all them are moved. Okay, so if you have to zoom, so everybody zoom. If you have to move, so or rotate, so everybody's rotate. The next one is the vector chart, a computer generated chart. Okay, means a computer generated chart. So it is chart is what do you call it? It is a load of the XDs. So it can rotate one side or it can zoom one or the other side. So you can manipulate the chart with moving one part and stationary the other part. It's not like on the raster chart. That is the difference between the two. If we have, you can zoom one part, okay, and the remaining will be at the same size. But in the raster, when you're zooming, so all parts will be zooming. You have to rotate, all part is rotate. Okay. So one example of the vector and the raster chart.